unit, we're going to talk about effects of electric current on substances, and we're going to talk specifically about electrolysis. Now, before we talk about this, let us ask ourselves one thing. What allows electric current to pass through a substance? What allows electric current to pass through a substance is the presence of one, mobile ions. So we are saying for electric current to pass through a substance, one thing that you need to have is the substance need to have what? We need to have mobile ions. We need to have mobile ions. We also need to have what? The presence of what? Delocalized electrons. So in absentia of mobile ions or delocalized electrons, electric current cannot pass through, or a substance cannot conduct heat, and a substance cannot conduct what? Electricity. So we talk about mobile ions when we are specifically talking about ionic compounds. And we talk about, so I'm saying mobile ions are for what? Ionic compounds. And we talk about delocalized electrons when we are talking about metals. Up to there, I hope you're fine, right? Okay, so now when we're talking about electrolysis, we are talking about we're talking about electrolytes. Now electrolytes are, for example, we have here lead 2 bromide, magnesium chloride, and lead iodide. These are what we are calling electrolytes. Okay, those are electrolytes. Now in electrolysis, what happens? We are going to dissolve or melt. We are going to dissolve or melt our electrolytes in the presence of heat. And when we are melting these electrolytes, we are saying in the presence of heat, thus it means we are going to decompose what? It is a process, or electrolysis is a process that involves decomposition of our electrolytes. Now, when you decompose something, you simply break it down. That is decomposition, right? Now, meaning if we are decomposing our electrolytes, that is lead 2 bromide, magnesium chloride, and lead 2 iodide, it means we are going to break these compounds, our ionic compounds, to form ions. So if it is lead 2 bromide, we're going to form which ions? Lead 2 ions and bromide ions. Magnesium chloride, you're going to form magnesium ions and chloride ions, and so on and so forth. So let us start. Now, this is a diagram representing the whole electrolytic process or electrolysis. As you can see here, we have the wire. This is your wire. You have a switch here, okay? And this represents what? Our battery cell. This is your bulb. You can see the filament inside there. And then you have this written as your anode and your cathode. Now, what are these two things? Easy happens. So these things that have been written as anode and cathode, refer them to as electrodes. Now, what is an electrode? We are saying this is an electrode. Okay. And also this, our cathode, is what we call an electrode. Okay. So what are electrodes in this case? We say electrodes are solid conductors of electricity. Now, remember, this is a molten ionic compound. So it can either be this, or any other molten ionic compound. We are decomposing it, okay? And we are going to have mobile ions. The mobile ions that are going to be present in this case, yeah, they are going to move freely to the electrodes. So the anode is the positive terminal. The anode is the positive terminal, okay? While the cathode is your negative what? Your negative terminal. Now, it is important to know this because these ions that you are going to have when electrolysis occurs, when decomposition occurs, they are going to move And the movement is going to be affected by a force where we say negative attracts positive, positive attracts negative, okay? So the negatively charged ions are going to move to the positive terminal, which is our anode, while the positively charged ions are going to move what? To the cathode, which is your negative terminal. Now, what happens in your anode? So we are going to take one ionic compound. In this case, we're going to take what? We're going to take lead to bromide and even magnesium chloride, and we talk about them. So what happens when you have molten lead to bromide? So let me write here molten lead to what? Lead to bromide. So during the decomposition of your molten lead to bromide, you're going to see the formation of red vapor. The red vapor is due to the formation of what? Bromine gas. Okay? Now, we are going to break our ions together here. We are going to say lead ions are positively charged, while bromide ions are negatively what? They are negatively charged. Remember, bromine is a halogen. Okay, and lead is a metal. So it has a positive charge, and bromine has a negative what? Has a negative charge. It is important for you to know that. So we are saying at the anode you're going to have, which is the positive terminal, we're going to have the negatively charged ions moving towards the anode. So here, this is our anode. So we are going to see what? Bromine what? Bromine ions moving towards that side. Okay? So as it moves to this side, what is going to happen is we are going to lose electrons. Okay? So we are losing electrons, and losing of electrons is going to occur. So we are going to lead to the, which is going to lead to the formation of your bromine gas. Okay, so the equation that is going to occur, the equation that is at the anode is going to be, the equation is going to be your bromine ions, which is aqueous in state, to form your bromine gas plus the 2 electrons that we're losing. Remember, this is the side of the product. The reactant is our bromine ion. That's why you can see it is the bromine ion. Forming a bromine what? Gas. Remember, bromine is a halogen and they are diatomic in nature. Thus, you can see that is why we're written Br what? Br2. Okay. So that is what is going to happen on the side of your anode. On this other side of the cathode, what is going to happen? You're going to see that you're going to have some deposits that are going to form along your cathode or your negative electrode. This is due to the deposition of what? The lead ions on the cathode. The cathode is negative, lead ions are positive. Negative and positive do what? They do attract. So the equation that is going to be there at our cathode is going to be, you have your lead ions reacting, okay, leading to the formation of lead metal, the solid particles that are going to attach on our cathode, okay? So we are going to do what? At the cathode, we are going to undergo a reduction. When reduction occurs, reduction simply means that we are adding or we are gaining electrons. So we are going to write plus our electrons. Remember, this is lead what? Lead 2 ions plus our electrons to form, plus 2 electrons to form your lead. Okay, so this is the reaction that occurs during the electrolysis of what? Molten lead to bromide. If you're talking about magnesium chloride, the equation that is going to occur is going to be what? On this anode side, you're going to have the negatively charged ions, which is the chloride ions, leading to the formation of chlorine gas. Okay, and now these are the 2 electrons that we are going to lose. So because we said here at the anode, we said we have what? Oxidation. When oxidation occurs, it simply means we are going to do what? We lose electrons. Okay, on our cathode side, this is, we are going to have your magnesium ions. Okay, gaining electrons, leading to the formation of your magnesium what? Metal, the deposits of magnesium metal along your cathode. So here we have said that the cathode we normally have reduction, So maybe I can move. You have reduction on this side. And what is reduction? Reduction is simply the opposite of oxidation. So when you're talking about reduction, you're talking about gaining of electrons. So something that you can use to help you to understand the whole reduction and oxidation process is oil rig. We say oil rig. Let me write here. We talk about oil rig. So this is going to help you to understand the whole oxidation and reduction thing. So oil rig means O is for oxidation, okay? Oxidation. I is loss. L is for loss. So oxidation is loss of electrons. While rig means what? Reduction. Reduction is gain of electrons. So this is one. So this is one mnemonic that you can use to understand or to remind yourself what oxidation and reduction is. So that is the whole process of electrolysis, and I hope you have understood what happens during the process of electrolysis. The most important thing you need to know is at electrolysis, you need to know the movement of your ions, where your ions going to move, and you're going to be guided by knowing the charge of your respective ions.